So that was our final posture detector prototype working there. So my role within this project was to physically build it and code it. It took a lot of research and work, but with the help of all the lads we got it to work and we're happy enough with how it turned out. The reason we chose to make this posture detector in the first place is because we thought it looked interesting, as it's a very common problem. A lot of people suffer badly with back pain, and a huge factor of this is because of poor posture. Also, we have an interest in health and exercise, so we all know the importance of good posture to keep the back injury free. So how does this work? The secret behind it all is the accelerometer, really. Everything else is simple enough, and so an analog accelerometer works on the principle of capacitive sensing. When the accelerometer is moved in any direction, then the capacitance will change. When this capacitance changes, then its analog voltages are changed. So this is what turns on the different LEDs, like according to what position your back is in. So then the device is powered by a 9-volt battery that's connected to the Arduino, and that's it. Overall, I really enjoyed building and coding this device, even though it was hard at times. But I couldn't have done it without the help of Owen doing the documentation work and submitting every assignment. And Colin and Connor done so much work, just researching and helping me to get the device working.
In this group project, I was the leader for the group. My job was oversee all the assignments and tasks that needed to be done. I would delegate jobs out and make sure everything was done on time. And if we had any problems, I would let Mike know, and we would organise a group meeting on Zoom and discuss our problem with Mike, and he would give us solutions to our problems. As you can see from the video, Colin just demonstrated how the prototype works. If you're in a good posture and your back is straight, the LED will shine green, and once you begin to slouch and fall into a bad posture, the LED will shine red. This is a very simple way for the user to know what kind of posture they are in. The device is a wearable one that goes across the front of your chest, so it is visible to see the LEDs. We wanted to pick this product because we thought it was very relevant in today's world, especially with COVID-19 and more people working from home or having lectures at home. This could develop bad habits on your posture from sitting on a chair all day. That's why we felt it was important to develop a prototype to try to prevent this. Some people might not like the idea of wearing it across the chest, but we think it is the best solution for this prototype, as you need to see the LEDs shine. But obviously, if you had a buzzer or noise alert, we would like to hide the components and make sure make it look a lot neater. But for the prototype we made, I think the design is most suited for it. We all helped each other out with all the assignments and jobs that needed to be done. Colin built the prototype and coded it from home. Owen was in charge of the documentation and sending in the assignments on time and making sure everything was in order and no spelling mistakes or errors was made. And Connor was a researcher, which he found out similar products on the market to ours and got information that made the development of the prototype a lot easier. If we were to develop the prototype more in the future, I would love to make it invisible and maybe have it on the back underneath your t-shirt. This would require making a buzzing sensation for the user instead of using LEDs, as you will not need to see the LEDs if you had a buzzer. Overall, I've gained more knowledge about coding and electronic systems when making this prototype, and I'm sure it will help me in the future.
In our group project, we decided to produce a posture corrector device. We were all assigned roles in the group. I was the researcher. I researched a lot of information about other similar products, and we brainstormed all of our ideas with what is already out there to make our device better. Colin made the physical prototype of the posture corrector device from home to an excellent standard, and he coded the prototype to function tremendously. Owen was in charge of the documentation. He made sure our assignments were presented to a high standard with no spelling mistakes and looking neat and clean. Colin was the leader. He got us organised, assigned us our roles, and made sure a lot of work got done for the project. The function of the device is to change colour depending on how you are sitting. If you are slouching, the device will turn red. If the position is acceptable, it will turn orange, and if it turns green, your posture is excellent. We picked the posture corrector device as out of all the ideas we had come up with, it seemed to be the best one, as it is a real life problem where people have terrible back problems due to bad posture. If we were to continue the project in the future, I honestly think it could go far. We could improve the device in nearly every way. Physically, it would look neater and cleaner. Secondly, with time to work on the device, it was an idea we had to add a buzz sound or a light shock to take action once you had gotten into a bad position, giving yourself bad posture. I learned a lot over the semester. My coding skills on the Arduino improved a good bit, although I am no master in any sense, I did learn a lot. I enjoyed the module and I found it surprisingly interesting. Thanks.
Hi, my name's Owen. My role within the project was to oversee documentation. This means that I was essentially in charge of all Word documents submitted by our group. In order to carry out this role, I had to gather information from all other members of the group with regard to their roles, their tasks, and any problems they may have encountered, as well as any other important information that was relative to the document or the assignment. I also had to learn how to make block diagrams that helped further describe the electronic circuit of our device. Although my role was to oversee documentation, I didn't complete all the write-ups on my own, but I had great help from the rest of the lads in our group. When we completed our write-ups, I would then thoroughly review the document, ensuring there were no spelling mistakes and correct any errors that may have cropped up. It was also my job to ensure that all the assignments were submitted on time and to a good standard. As previously seen in Colin's demonstration, the posture corrector device we designed, coded and constructed was a great team effort, and it's something I'm really proud of. I won't go into too much detail into the electronics, given that Colin has already given a full description and explanation of how it functions. However, in short, when the accelerometer detects that there is a change in the user's posture, it triggers the red LED to turn on and the green LED to turn off, indicating to the user that they need to adjust their posture. Although I preferably would have liked to use some sort of sticky adhesive that would have allowed the device to attach the user's back, this just wasn't possible during the time frame. So we instead opted for a strap mechanism that would wrap around the user's upper body, and then the posture corrector device would sit on the user's chest. This ended up working out extremely well, and it was surprisingly comfortable to wear. So if we were given more time on the project, I definitely think we could have made a more discreet posture corrector device by minimizing its overall size, which can make it more appealing to potential users. Overall, I definitely think I learned a huge amount from this project with regards to electronics and coding, but furthermore, I've also been able to greatly develop my communication and teamwork skills from working alongside Colin and Connor, who were excellent team members throughout the entirety of the module.